Level 3 methods do not develop overnight, and they can't be developed in an individual lesson. It requires ongoing efforts to foster this kind of thinking. I use the metaphor of a crock pot rather than a microwave. Instead of cooking the meat at a high temperature for a short time, we can put the heat on low and cook it for a long time, and that way we get especially tender and tasty meat. Getting back to our math strategies, what we think of here is that rather than developing this kind of thinking through intense and isolated efforts, we can more easily foster meaningful strategy development by using shorter, more ongoing efforts. Number talks are growing in popularity as a tool for fostering this kind of strategic development. Number talks are very different from a typical math lesson. They're much shorter, for one thing, and your primary focus is most definitely not on what you can cover or what you can present or what you can accomplish. In fact, the focus isn't on anything that you do at all. The entire focus is on what the students will do when presented with a computational task. How will they think about it? What strategies will they employ? Do those strategies work? How do those strategies compare to something that another individual tried? A number talk is a breeding ground for student thinking, so the teacher's ideas are really out of the picture completely. The role of the teacher here is to pose tasks that will elicit the student thinking, and or to pose a sequenced set of tasks that have an inbuilt suggestion of a strategy that could be useful. Not that everybody will try that strategy, but there's a sort of inbuilt suggestion. The teacher also models the student's thinking, often with number bonds and equations, and ensures that the dialogue that the students are experiencing is focused on mathematical relationships, keeping them on target with focusing on those mathematical relationships. In order for number talks to achieve their potential in the curriculum, there are some criteria that need to be in place. A key aspect of number talks is that they need to be a low-risk environment. In other words, learners must feel free to take risks, try out ideas without the fear of being wrong. If there's a stigma to being wrong, they will play it safe, and it will be very difficult to get them to try out new strategies. Now, this does not mean that all answers are treated as if they're correct. Rather, the format is to be okay with the idea that sometimes we'll be wrong. Why? Because when we make a mistake and we explore it, we learn more deeply than we knew before. So the mistakes are opportunities for deep learning. So a number talk needs to have some norms that communicate this idea of an open and accepting community to students. Some teachers actually pose a computational task, and before any discussion of the exact strategy that was used, they collect a whole variety of answers or possible solutions that the students had in their mind. These are proposed ideas that it could be, based on what I did quickly in my mind, it seems like the answer might be this. Then they provide an opportunity for the learners to use their estimation skills to decide whether they think that any of the answers that are up there are unreasonable. This is a wonderful opportunity to develop mathematical standard of practice 3, where they construct viable arguments and critique the reasoning of others. During this stage of the number talk, children are focused on the mathematics and not on the individuals. They learn how to effectively critique an idea, not a person. Throughout the experience, the focus is on whether your argument convinces the individual to change their mind, and the basic premise is that learning anything meaningful will require us to be in a position where sometimes we change our mind because we're learning new things, and that's influencing us. Other features of number talks include a focus on student dialogue and the non-judgmental reaction of the teacher. The teacher is no longer the judge of what is right and what is wrong. The students critique and contribute. Even when someone is incorrect, instead of saying that, we elicit more student responses and student reasoning to critique all of the answers, the right ones as well as the wrong, so that students can learn to develop their own capacity to evaluate and judge their answers for correctness. Finally, not all computation problems lend themselves to strategic development, so we need to carefully choose the tasks or problems that we provide. Now, initially, this may be a big concern. If you worry about how to form your own number talks, I do have some resources that I suggest at the end of this lesson that are well worth the investment. The number talks vary considerably, but at the first grade level, they generally progress from lower levels of abstraction to higher levels of abstraction. And this may involve more concrete or visual images first, followed by number bonds and equations after. Or it might involve starting with problems that are very easy to the vast majority of the students initially, and then gradually through the sequencing, build up to more difficult ones. The intentional sequencing then can suggest a strategy without you having to draw their attention to it verbally. In other words, the numbers speak for themselves, so that some students will see an advantage to doing that. Multiple representations and dialogue that get students to see how the representations are connected also supports learner strategic development. So it isn't just that you have more than one representation, it's the back and forth connection. So for example, equations are something that we want to have meaning. If they have a strategy and you write an equation, are they connecting what you're writing to what they did in their minds? And although we've said it before, it bears repeating that the focus here is on the student thinking, and it should be an environment where it's okay to be wrong. The exploration of wrong answers can benefit us by helping us develop deeper understanding of the mathematics. When you sit down to plan a number talk, here are some good questions to guide you. Initially, this will take you a while, but as you get a mindset for how number talks work, they will come together much more quickly and naturally. Basically, you need to choose representations that will connect with your learners, keeping in mind that they need to become accustomed to using more than one kind of tool so that they can see transference of the mathematical ideas across tools. Sequencing of the tasks is especially important when you want to get some new strategies in your students' repertoire. We will take a look at that component in a minute. You need to consider what important ideas that you hope the dialogue will uncover so that you can be looking for the opportunities to extend a student's thinking to get at those fundamental mathematical ideas. And also consider what you want to intentionally model. Math is often difficult for children because of its abstract symbolic language. Children need extensive opportunities seeing the language of mathematics modeled in ways that will connect with their thinking. Number talks are a great way to build in this long-term teacher modeling. Now, especially when the number talk brings out some new ideas that are not yet solidified, you may also want to plan a reinforcement task that could be used in a follow-up lesson or at a math center or as math homework. The handout that follows this lesson in the Teaching Resources section provides some examples of some reinforcement tasks. The first question that we discussed involved carefully choosing representations. Typically, a number talk will include at least 2 representations, depending on what tools you make available and how you model student thinking. Here are some examples of representations that are very useful at the first grade level. The math rack that you see at the bottom left is actually homemade. I made it out of a Weight Watchers frozen meal dish. I poked 2 holes into each side, ran some lanyard string through, and strung 5 red pony beads and 5 white pony beads. I think you can get these at Walmart. And I strung them onto string. I got my supplies very cheaply, and I was able to make a complete class set of these. Now, the way a math rack works, you only read the left side. So the current setting that you see in this image shows the number 12 with 5 red beads on top, 5 red beads on the bottom, and then 1 white bead on top and 1 on the bottom. Fingers are an excellent and very handy representation since you always have them with you. This image here at the top right shows 8, represented as 5 on one hand and 3 on the other. Notice that the interesting thing about using fingers to represent number is that each hand decomposed. I mentioned earlier that the number talk can be sequenced so that the beginning part of the number talk can use either easier number facts or else more concrete representations than the later part of the number talk. You would not have a number talk that uses all of these representations, by the way, that you see here, but this particular mapping illustrates that there are tools at different levels of abstraction, and you can actually pull from this list and decide which representations might be suitable for your learners based on where they are in their learning journey, what kind of knowledge they're connecting with. Generally speaking, though, you want to start your number talk out with something that the vast majority of your learners can connect to and that they will see as being easy and perfectly understandable. Very, very yes, of course. And then gradually you're going to take them towards more abstraction within the same number talk. By starting with something that they see as really easy, you give every learner an entry point into the learning so that they're not alienated from the beginning. They're engaged mentally, and then you take them as far as you can incrementally towards a further step of abstraction. Student thinking is the linchpin of the number talk, particularly student thinking about mathematical relationships and properties, and then how to use those relationships and properties strategically. So give some thought in advance about what kind of student dialogue you hope to elicit through your chosen tasks. Here you see several ideas for focusing the dialogue at the first grade level. I'm not going to go through each of these individually because a number of them have come up in previous lessons, but feel free to pause the presentation and take a look at those. If students are going to get the most out of a number talk, there needs to be widespread student engagement. We can't afford to have just a few people participating and a number of people mentally off task. So we really want a situation where every student perceives that their involvement is required all the time, not just some of the time. And that means that when another student is sharing their thinking, that all of the other students perceive it as a responsibility to do their best to make sense of that child's thinking and to follow along. So you need to really set some norms, some classroom norms for what goes on during this number talk, and this should involve incorporating explicit guidelines that clarify what their role is, both during the think time portion and during the sharing time, both when they are listening during sharing time and when they themselves are sharing. You can do this through a number of ways. One way that I've done this is through a looks like, sounds like T-chart, where you think in advance and clarify for students about what it should look like while you're doing a number talk, what it should sound like. I also really like the use of dipsticking signals. The signals give the child a way of communicating to me without interrupting the whole class or anyone else's thinking. And they also give me some formative feedback about what's going on. So as I look through a whole class, I can quickly get some feedback about where they are. I know when they have a solution. I know how long it took them to get a solution. I know how many strategies they've found. And I know when they agree with someone else or if they use the same strategy, all with no talking, just by a signal that a child can give me. The initial signal for I'm thinking can be to put a fist on their chest, and when they have a strategy, they put out one finger from their fist. And then they are to think of another strategy, and when they have that, they can put out an additional finger. That means that students who are very quick on their feet coming up with strategies don't mess around thinking that they're off duty once they have it. Rather, they should keep thinking of a second strategy. When a student shares their thinking, the other students can use signals to indicate whether they agree or disagree, whether they use the same strategy or not. These signals put all of the students in a mode where they're constantly responding and thinking and participating, even when they are not the one who's talking. Don't feel alarmed if everyone in your class doesn't immediately pick up on the target concept that you planned. If everyone picks up on it immediately, it's very probable that that number talk was not really needed that day. You normally expect that a certain portion of your class is going to pick up on a new target concept immediately, and that others will listen and follow along, and they're in a sense-making mode, beginning to catch on, but they're not necessarily ready to try it on their own right now. And then you may have a few students who are really not sure at all about it. As that same target concept shows up in future number talks with different numbers and different tasks being posed, you can then monitor how the learners are responding, and you should expect to see that more and more students are catching on to the target concept. This is one of the beautiful things about a number talk. Children are allowed to naturally develop understanding in a low-risk environment where they don't feel obliged to do something that they can't make sense of just because they're afraid that they'll be judged if they're not doing it. Although your tasks are designed to get the students to discover a new strategy or ponder a mathematical relationship, they are constructed in such a way that the children can own that discovery. So you can celebrate that discovery by developing a class chart of the ideas that the children have been able to come up with, the new strategies that they have uncovered. And then you can refer to that chart as they're doing other tasks. Oh, look, now we're in problem-solving time, and I see somebody's used this strategy that we had during our number talk the other day. So you can build this idea that the strategies that are grown and discovered during that number talk can be transferred over into the other tasks that they're doing. In addition to Level 3 strategy development, number talks are ideally suited to address several of the mathematical practice standards. The focus is on children's thinking and reasoning, which they articulate, and they also respond to their peers' thinking, deciding if they agree or not and justifying why. These two elements get at mathematical standards of practice 2 and 3. Now, the teacher is actually modeling a number of mathematical standards of practice, and by experiencing that ongoing modeling, children can begin to own some of that process and begin to try things out for themselves. So some of the things teachers are modeling is the use of visual tools and equations that can support children in the mathematical standard practice of 4. Many of the representations the teachers use will involve strategic use of tools, so appropriate tool use can also be facilitated, getting at mathematical standard of practice 5. The teacher can model, facilitate, and evaluate children's precise use of mathematical vocabulary and precision in calculations, which gets at standard of practice 6. Strategies are typically based on number relationships, and so children may be taking advantage of structures within our number system. For example, structures related to place value. Looking for ways to take advantage of the mathematical structure of numbers is tied to mathematical standard of practice 7. Therefore, number talks are a wonderful way of to daily experience and develop children's mathematical habits of mind. I should point out that an individual number talk, a given particular number talk on a given day, will not accomplish all of these standards of practice. If it tried to, it would be so watered down as to be not particularly useful. In indicating the potential of number talks, I pointed out that a variety of standards could be addressed over time. You will have much more success in using number talks well if you have a specific focus for the dialogue. For example, early in the year, your primary focus may be just to get the students reasoning and explaining. You can model and use tools that benefit them from seeing you do this, but the primary focus area of the dialogue is to facilitate their reasoning skills. You may choose a particular sequence of computations that draws heavily on the patterns in the number system, and in this case, your focus for the dialogue for that day may be primarily focused on this mathematics of the pattern, rather than on reasoning. Again, you can focus on the model, but you're not focusing on the model, but the mathematical structure. The model is just a tool to help you see the mathematical structure. So give some advanced thought to what your dialogue target standard of practice will be for that particular number talk. If you develop a consistent commitment to number talks in the classroom, and you ensure that those number talks involve very specific computation experiences that can draw learners' attention to mathematical relationships, that allows them to make sense of and leverage level 3 strategies, and if it gives them opportunities to explore why methods work and critique the methods, then number talks will become one of your favorite ways to ensure that the mathematical standards of practice characterize the kind of instruction you have in your classroom. The Common Core authors have been very clear that the mathematical standards of practice are not just for gifted children, and they aren't the sort of thing that you delegate to Friday afternoons. Rather, they should be the day in, day out characteristic of how math instruction occurs in your classroom, in the same way that the content standards are the what of instruction. Number talks often have one of these particular formats or structures. Sometimes they're a sequence of quick images using visual representation such as 10 frames or dot arrangements. They may begin with familiar images and then gradually change so the child begins to see how they can mentally transform an arrangement to make it easier. We'll look at an example of that in a minute. A string is a sequence of carefully chosen number sentences which has an inbuilt suggestion of a strategy. They typically start with an easy problem that you're sure your class can do very well, and ends with a hard one that they might believe is too hard, but the intermediary number sentences offer a scaffolded suggestion for how they can transform it into an easier problem. In other words, an inbuilt suggestion of a level 3 strategy they could use. A mental math problem is chosen to take advantage of mathematical relationships. Not every child will see that relationship instantly, but you can have a strategy share around reasonableness of answers. And once a class has decided on the accurate answer, they can discuss the efficiency of the strategy. This dialogue can help the class see that taking advantage of a particular mathematical relationship can actually be very advantageous in helping you to make a hard problem easier. This is an example of a quick image sequence. Only one card is shown at a time. It's only shown for a very short time, so the child can't actually count each dot individually, and it fosters the idea of adding chunks. So you show the first image, followed by a short think time, which allows the child to mentally process the chunks that they saw and put them together in their mind using a strategy. This process is called Conceptual Subitizing, and it's the foundation of many arithmetic strategies. In fact, these visual images are really where they begin to build a strategy. You can then call on children to share the strategies that they had, and a child might say something like they saw 2 groups of 3, and they knew that was 6, but then there was one more, so that makes 7. Now, if you want, at this point, you could then model that as an equation on the board to represent the thinking of that child, writing 3 plus 3 plus 1 equals 7. Classmates can then give a sign of agreement or disagreement about whether they agree with that particular strategy and solution. The next image shows a cluster of 4 dots and a cluster of 3 dots. Will the child see that this is basically the same as the first card? Will they be able to see that the 4 can be decomposed into a 3 and a 1, allowing them to take advantage of that known doubles fact? This is the question that you have in mind, and you're pulling out student strategies to see if anyone's uncovered this idea. Once it's out in the open, you can ask the children to explain it to one another, and you can then model it with number bonds or equations. There are 2 examples of strings here. The first string uses a math rack with a different combination of beads in each section. If you take a look at it, you may notice that they're all combinations of 8. You can tell a story as you make these arrangements. Some of the more common story contexts for the 2 rows of the math rack involve the top and bottom bunk on bunk beds, or the top and bottom level of a double-decker bus, or a top branch and bottom branch with birds on a tree. The second and third arrangements under the math rack example foster a dialogue about the concept of the commutative property, although you shouldn't necessarily use the term commutative property with them, the concept they need to have. The overall string also fosters thinking about compensation. Why is 4 on the top and 4 on the bottom the same as 3 on the top and 5 on the bottom? Oh, one moved from the 4 on the top and joined the 4 on the bottom. So which one's easier? If we don't know 3 and 5, can we turn it into 4 and 4? The second example might be used later in the year when children are more capable of making sense of equations. If your students readily are able to create stories to match an equation, then they can do number talks like this occasionally. This one uses doubles as anchor facts, and it also uses the idea of compensation that we just got done discussing with the math rack example. And rather than a string of computation problems which suggest a strategy, you may just want to pose 1 or 2 problems and then allow more time for them to share strategies and have a dialogue around the ideas that are being uncovered. Here are a couple of examples that provide an opportunity to use compensation, although not all children will do that. But someone might mention that 9 is close to 10, and they don't know 10 and 8 is 18, so it would just be 1 less. Or they might say that they broke the 8 into a 7 and a 1 and gave the 1 to 9, so now it's 10 plus 7. If you have a few students using these powerful level 3 strategies, a number talk is a good way to get that idea out to the rest of the students and have them pondering why it works. Unless you've had some experience with number talks, you may be feeling a little overwhelmed designing your own. Here I have a list of some of my favorite resources. The bottom reference is actually an article that gives more background on number talks. And the second and third references here essentially are resources that are just filled with